3.1 Lines and Angles. Our objective in this lesson is that we are going to identify relationships between figures in space and, very importantly here, to identify the angles formed by two lines and a transversal. Our first vocabulary here is parallel lines, and you should be familiar with these. Parallel lines are coplanar, means they lie in the same plane, and they do not intersect. And you should know this already. This is nothing new. We have our symbol here that means is parallel to. And I tend to write mine at a little bit of an angle. You can too. It doesn't matter. That just means parallel. So let's look here on our diagram. We show that line AE, so there's line AE, is parallel to line BF. Okay, that's not a shocker at all. And line AD, there's line AD, is parallel to line BC. Okay, again, just on our box. Now you'll notice here that line AE and line BF have those markings. Those markings mean parallel. And our line AD has two of them, as does line BC. Those indicate parallel. And just like our congruent markings, the same number means you're parallel to that line. So we have one parallel mark means those lines are parallel. Two parallel marks means those lines are parallel, but not parallel to the other lines. Next, skew lines. Now this might be a new term for you. Skew lines are non-coplanar. They are not parallel, and they do not intersect. So these are some very important ideas for us here. Not parallel and do not intersect. So let's go over to our diagram and find some skew lines. Line AB, so this line right here, is skew to line CG. And line CG is back here. Notice they are not parallel, they're not coplanar, they're not parallel, and they do not intersect. So be careful when you're looking for skew lines. And last here, parallel planes are planes that do not intersect. So it's just like lines. All of our lines in our parallel planes can be parallel as well. All right, another big idea here. A line and a plane that do not intersect can be parallel. So you can have a line that is parallel to a plane. Also, segments and rays can be both parallel and skew. Now, they're parallel if they lie on parallel lines, right? Segments and rays are just pieces of our lines. So if our lines are parallel, the segments and rays within those lines are also parallel. And if our lines are skew, then the segments and rays within those lines are also skew. So that should make sense. Let's look at some examples here. In the figure, assume that lines and planes that appear to be parallel are parallel. If you see this, then you are allowed to make that assumption. We are told that we can make that assumption. This way, everything does not have to be marked. So when we look at our diagram here, we just see a box, right? You will learn that it is a rectangular prism. But we can assume that that our front and back are parallel, our right and left are parallel, top and bottom are parallel. So that is a really useful statement. It means we have to read all of our directions. So our first question here is, which segments are parallel to segment AB? So the first thing we're going to do is identify segment AB. And we can see that segment EF is parallel. That one makes sense. Segment DC is parallel. Segment HG is parallel. Those make sense. Those are just the corresponding sides there. All right. B, which segments are skew to segment CD? So we're going to identify CD here, and we need something that is skew to that. Remember, skew means not parallel, and they don't intersect. So let's see, BF, segment BF is skew, not parallel, does not intersect. Segment AE is skew, not parallel, does not intersect. EH, look at this guy down here. He's not parallel and they are not going to intersect. And FG, now notice segment FG. Notice about the segments that we chose. They're very similar to each other, aren't they? We have these two over here on the left are parallel, those two on the bottom are parallel, which makes sense because that would mean they are not parallel to segment CD. Okay, next, name some parallel planes. Well, let's see, plane ABCD. ABCD is our top here, so who's going to be parallel to that? Well, this plane down at the bottom, plane EFGH. And don't forget, we have to name the points in order. You cannot lift your pencil. And plane DCG. Well, DCG goes right there. What plane is that? Remember, we could name a plane with only 3 letters. It's going to include H. And who's parallel to that? Well, ABF. And notice the order of those. We started here at D, went back to C and down to G. Notice we went A to B to F. Right now, order doesn't matter, but it will. So it's good to start paying attention to it. Okay, so those are our left and right sides. And finally, name 2 segments that are parallel to plane BCGF. Well, where's BCGF? BCGF, it's not the color I want. BCGF is back here in the back, and this might be a good time to erase all of this so that we can see what we're doing. That's why we use colored pencil, so that we can erase and see what's going on. There's plane BCGF, and we want 2 segments that are parallel to that. Well, we have a couple of choices here. We could go segment AD, that one's obviously parallel, but so is segment DH, because there are segments on this other plane that could be parallel. We could also do a diagonal segment, couldn't we? That would still be parallel because it is in the plane that is parallel to that back segment. All right, all of those are good. Now go ahead and you pause the video and do the next few problems. See how you do on these. All right. First question says, which segments are parallel to segment AD? Well, AD is right up here at the top. So we know that segment EF right down below it is parallel, segment BC in the back, segment FG in the back. Those should be pretty straightforward. Those are our parallel planes front and back. The next one is explain why segment FE and segment CD are not skew. Well, segment FE and segment CD are parallel to each other. And we know that skew lines are not parallel and do not intersect. And then we are asked to find another pair of parallel planes. And we already did the left and right and top and bottom in the example up above. And so that leaves the front and the back, which is plane AEHD is the front, and plane BFCG or GC, sorry, is in the back. And then what two segments are parallel to plane DCGH? DCGH, this plane is the one on the right side over there. So we know that all of these over here that are in the left side, that plane over there would be parallel as well. And if you put in diagonals, that would be good as well. All right, so some terminology for us to use. Now we get into the fun stuff. This is going to be hugely important here in Chapter 3 on parallel lines. When a line intersects two or more other lines, the angles formed by the intersection points create special angle pairs. Okay? Special angle pairs are going to be huge for us. So we have two lines here, and they are being intersected by this third line. This line is called a transversal. This green line here is our transversal. Your transversal intersects two or more coplanar lines. We have lines that are, or when our lines intersect, we have angles that are inside. Right? See here, angle 3, 4, 5, and 6. They are in between, they are inside our two lines that are cut by our transversal. And we have angles that are outside. Right? 1, 2, 8, and 7. Notice how they are outside of our two lines that are being cut by our transversal. Those are exterior angles. So we have two lines cut by a transversal, and they form these special angles. And we have interior angles and exterior angles. Now let's see what we're going to do with those. We have special names for these that are suggested by their positions. So position is going to be important to us. First one, alternate interior angles. What does alternate mean? It means it like goes from one side to the other. And interior, these are opposite sides of the transversal and on the inside of our lines. Opposite inside. Alternate interior angles are non-adjacent, so not next to each other. Interior angles that lie on opposite sides of your transversal. So let's look over here. We have, I need a new color, angle 4 and angle 6 are alternate interior angles. Let's see if I can get a green one. Opacity. Down to like 50, see if this works. It does. And 3 and 5 are alternate interior angles. Okay, do you see how they are on opposite sides of the transversal and in between the lines? So we have two pairs of alternate interior angles. Okay, let's do the next one. Same side interior angles. Guess where they're going to be? They are interior angles that lie on the same side of the transversal. They say exactly what they are. So let's look inside our transversal here. And angle 4 and angle 5 are on the same side of our transversal. And I need to get this pen. So are angle 3 and angle 6. All right, do you see how we have same side interior angles? And if you're doing these, use different colors for these. Or just do one pair of angles. Because this is going to be your reference for when we use these special angle pairs. Special angle pairs are your friends. All right. The next two. Corresponding angles. What does the word corresponding mean? Correspond means it's like the same. It's got our co-prefix. It means they're going to be together. Corresponding angles are on the same side of the transversal and in corresponding positions. So these are in the same place. So, for example, you might be left of the transversal and above the line. So let's go find that one. Who is left of the transversal and above the line? Angle 1 is. Now let's look at our other line. Left of the transversal and above the line. Those are corresponding angles. All right. Who else is corresponding? Well, angle 7 is to the right of the transversal and below the line, and so is angle 3. And this works for all of these angles. Angle 4 is below the line and to the left of the transversal, so is angle 8. Angle 4 and angle 8 are corresponding angles. Angle 2 and angle 6 are corresponding angles. So we have lots of pairs of corresponding angles. Corresponding means in the same place. Okay, and this is one of our favorites. We are going to use alternate exterior angles are rarely used. They're good though. Alternate interior angles are one of our favorites. Alternate exterior angles are non-adjacent, important, exterior angles that lie on opposite sides of our transversal. So these are opposite and outside. So let's go find a couple of these. Well, angle 1 is outside. And who is on the opposite side of the transversal and outside? Angle 7. There we go. Angle 2 is on the outside of the lines, and so is angle 8. So those are our alternate exterior angles. Okay. Let's try some problems with these. Which is a pair of alternate interior angles? Well, the first thing we need to do is find who is inside, right? Interior. This means opposite and inside. So angle 2, angle 7, angle 3, and angle 6 are inside. So anybody but them does not count. And who is opposite? 2 and 6 are opposite, 3 and 7 are opposite. So let's go look at our choices. Angle 1 and angle 3. Angle 1 is outside. So that one doesn't count at all. What about B? Angle 6 and angle 7. Angle 6 and angle 7 are both inside, but they are on the same side, so those don't count. What about C? Angle 2 and angle 6. Yay! Let's check the last one just to be sure. Angle 4 and angle 8, both of these are outside, so neither one of those. So our angles are angle 2 and angle 6 are alternate interior angles because they are on opposite sides of the transversal and in between our two lines. All right, so go ahead and pause the video and you do the last two problems. Okay, it said use the figure in problem 2. What are 3 pairs of corresponding angles? Remember that corresponding angles are in the same place. And notice that I have marked my transversal in green because our angles are positioned on that transversal. So it's always good to know where your transversal is. So my transversal is in green, and corresponding angles are angle 1 and 3, 2 and 4, 8 and 6, 7 and 5. I named all of them, just in case. So to the left or above the transversal to the left of the line, above the transversal to the left of the line, depending on which position. If you have difficulty seeing these, then turn your paper so that your two lines and your transversal are in the same position as your examples. That is a hint that I will always give you. If you are trying to compare it to the examples in your notes and you're having trouble, notice this time our lines are up and down and our transversal is right and left. But in all of our examples, it's the opposite way. So you can simply turn your paper and it might be easier to see. All right, and then we were told to classify all of our angle pairs. Well, we already did the corresponding. Alternate interior are our two inside ones here, angle 2 and 6 and angle 7 and 3. Same side interior are again inside, only this time on the same side of the transversal, so angle 2 and 3 and angle 7 and 6. Alternate exterior, these are the ones that are outside on opposite sides, so angle 1 and 5 and angle 8 and 4. And then I also put in here, because these are our special angle pairs that aren't special. These are angles that are going to follow us and we should be actively looking for. Notice we have vertical angles, angle 1 and 7 and 2 and 8 and 3 and 5 and 4 and 6. Okay, those are, we have intersecting lines, so we have vertical angles, and anytime we have intersecting lines, we have linear pairs as well. Notice that our linear pairs over here on the left side, we have 1 and 2, and 1 and 8, and 2 and 7, and 8 and 7. So we have 4 pairs of them over there, depending on which line we are looking at. And it's the same on the right-hand side, 4 more pairs, 3 and 4, 4 and 5, 5 and 6, and 6 and 3. So these are very important. You need to actively look for all of these angle pairs. We have 6 of them now, alternate interior, alternate exterior, corresponding, and same side interior, that we have added to our vertical angles and our linear pairs. So this is going to be a good reference sheet for you. Keep it handy. And we are done with this lesson. Have fun with the homework.